So our first question wanted to know the scale factor from triangle ABC to triangle DEF. So this was our old or our original, and this was our new image. So our scale factor, how are we getting from our old to our new? Well, how do we get from 10 to 20 times 2? 6 to 12 times 2, 7 to 14 times 2. So our scale factor is 2. Now the other way we could check, we could say constant of proportionality, or K, equals new over original, or new over old. Our new is 12. Our old is 6. 12 divided by 6. Again, we get the same answer of 2. And if we checked it with our other side lengths, it would work as well. New divided by old, 14 divided by 7 is 2, or 20 divided by 10 is 2. In question 2, they told us that the rectangles are scale drawings, which means they are in fact proportional. So looking at this, how do I get from 7 to 28 times 4? So I would need to do that same thing to get from 5 to x. 5 times 4 is 20. Or if we wanted, we could set this up as a proportion. 5 over 7 equals, again, the 5 corresponds with the x, so we would want those across from each other. And the 7 corresponds with the 28. Again, we can see this relationship times 4 times 4. Or if we wanted, we could cross multiply. X times 7 is 7x equals 5 times 28. 5 times 28 is 140. Divide both sides by 7 to isolate our x. We get x, x equals 20. Okay. In number 3, Jamie made a scale drawing of his apartment building. The building is 300 feet tall. He wants the scale to be 1 inch for every 10 feet. How tall should his building be in his scale drawing? So we have 1 inch for every 10 feet. We want to know if it's 300 feet tall, so keep my labels consistent. How many inches? Again, we could cross multiply to solve for x, or in this case, 10 times 30 is 300. So 1 times 30 is 30 inches. The triangle on the left is the pre-image. So this is our triangle on the left, ABC. This is our pre-image, or our old or original. So this is our new. We can see that our original is larger, our new got smaller. So we know this is a reduction. If it's a reduction, we know our scale factor is less than 1. So because of that, we know that 2 is out. And because this fraction is improper, it's actually more than 1. So A and B would be out. What is the scale factor? So again, we can do K, our constant of proportionality, equals new over original. Find corresponding sides, so we can look at 3 over 6, which simplifies to divide by 3, 1/2. And then we can check it for our other side. Half of 10 is 5. Half of 6 is 3. So our scale factor is in fact half. Find the perimeter of the large triangle. Remember, perimeter is the distance around a shape, so we add up all the sides. Before we can add up all the sides, we need to find this missing length. So how do I get from 3 to 9 times 3? My corresponding side here, the 5 and the 15, is times 3. So to get from 4 to this missing side, we have to do times 3. 4 times 3 equals 12. To find the perimeter, we now need to add these 3 lengths. So 12 plus 15 plus 9. 12 plus 15 would be 27, plus 9 we would get a length of 36. Would be. In question 6, they're telling us triangle ABC is similar, this little squiggle means similar, to triangle XYZ. We want to find the side length of X. So looking at our corresponding sides, we have side AC and XZ are corresponding, and 25 and 10 are corresponding. Now I have this information about 8, but I don't have the information from C to B, so I wouldn't use those corresponding sides. So next I would set up my information in a proportion. I have X and 25, and I'd keep my corresponding sides across from each other. So the X goes with the 6, and the 25 goes with the 10. From here, we can cross multiply to solve for X. So X times 10 and 6 times 25. X times 10 is 10x equals 150. To solve for X, we isolate our variable. X and 10 touching means they're being multiplied. So we're going to use the inverse operation of division to get X by itself. Divide by 10, we get X equals 15. A map has a scale of 1 centimeter for every 5 kilometers. On the map, 2 cities are 3 centimeters apart. What is the actual distance, so in kilometers, between these cities? So again, 1 centimeter for every 5 kilometers. We want to know about 3 centimeters. So I'm going to put the 3 on the top to keep my labels together, centimeters with centimeters. How do we get from 1 to 3? Times 3. So in the bottom, we have to do that to our kilometers as well, times 3. And 5 times 3 is 15. On a map, Memphis, Tennessee and Jackson, Mississippi are 5 inches apart. So that's on the map. The distance between the cities is actually 210 miles. So we have 5 inches on the map, and then their actual distance is 210 miles. What scale was used to create the map? So on our map, we want to know 1 inch is representing how far. So we could divide by 5 or times 1/5, times 5 is reciprocal. Let's do division for now. Divide by 5, we get 1. And divide by 5. 210 divided by 5 is 42. So 42 miles for 1 inch. 42 miles for, okay, so they're trying to trick me with with answer A, right? 42 inches in 1 mile. I have the correct numbers here, but my labels are backwards, right? It's not 42 inches on my map, it's 1 inch on my map. for every 42 miles. So B, 1 inch for every 42 miles. So question 9, it wants to know the scale factor. Now this has an X here, so you could be tempted to find this missing value, but it's actually asking for the scale factor. I think there should be a little more information here. Let's say that this is the original shape and this is the new shape. Well, how do we get from our original to our new? Times 4. So if they told me that this was a proportional relationship, our scale factor here would be 4. Number 10, Pam drew a scale drawing of a game room. She used the scale 1 inch for every 2 feet, 1 inch for every 2 feet. If the air hockey table is 5 inches in the drawing, how long is the actual air hockey table? So how many feet? Again, we could cross multiply, or we can see 1 times 5, so 2 times 5. To keep it proportional, whatever I do the top, I gotta do to the bottom. So 2 times 5, our actual length would be 10 feet. Irene measured a shopping center and made a scale drawing. The scale she used was 2 inches for every 1 foot. If a bakery in the shopping center is 104 inches in the drawing, how long is the actual bakery? So 104 inches, inches with inches. How long is the actual bakery? The actual bakery is measured in feet, so feet with feet. We could cross multiply. 2 times x is 2x. Switch colors. Equals 104 times 1 is 104. To solve for x, we'd have to divide both sides by 2. So we get x equals 104 divided by 2, which is 52. On a map, the distance between Louisville, Kentucky and Nashville, Tennessee is 1 3/4 of an inch. The scale of the map is 1 inch for every 100 miles. So 1 inch for every 100 miles is our scale. What is the actual distance between the two cities? So on the map, we know it's 1 3/4 of an inch. We want to know the actual distance, so how many miles. Okay. Well, we can do 1 times 1 3/4, which means we have to do 100 times 1 3/4. 1 3/4. Now, before I can do that, I have to change my fraction into an improper, my mixed number into an improper fraction. We can do times plus. So 4 times 1 is 4, plus the numerator is 7, over the original denominator of 4. So now we can go through and do 100 times our 1 3/4 as an improper fraction. How do we change 100 to a fraction? We put a 1 underneath, and then we multiply straight across. So 100 times 7, and 1 times 4. Again, this line means divide. 700 divided by 4, if we do it out, is 175. So x is 175, and x was in